In the today's session, I am going to explain about a method of extraction which is very important examination point of view, percolation. It is otherwise called as lixivation. Lixivation also. Percolation is a method of extraction based on the principle of displacement. Displacement of slow passage of menstruum by the gravity. Simply speaking, this is a rough diagram of a percolator. A conical shape. We have two types, cylindrical or conical shape. Generally, we prefer the conical shape, right? It is having a port for the removal. Here we keep a cotton plug. Take the powdered crude drug, or you can say granulated crude drug. You pack it here after imbibition and you pour the sand here. Solvent, after that you pour the solvent. Solvent is passing through this one. So solvent is passed through. Solvent is passing through the packed bed. So percolation means pass through. Pass through. Okay. What are the various forces influencing the process of percolation? Gravitational. By gravity only solvent is passing from top to the bottom of the packed bed. Viscosity of the solvent, wetting property of the solvent, adhesion and friction between the particles, osmosis, that is I said about the endoosmosis, dissolution, exoosmosis, the process of entry of the solvent into the particles is called as the endoosmosis, and dissolving the active principle, dissolution, and solutions coming out from the cell wall or the particle to outside, it is called as the exoosmosis, right? And capillarity, each cell wall is having some pores or capillaries. It may be having some air, it has to be removed, then solvent can enter easily. Capillarity, surface tension of the solvent, and dissolution rate, depending upon the active principle inside, choose the solvent. Polar active principles are there, choose the polar solvent, like that. Here we can divide the entire process into three stages, that is imbibition. Take the crude drug, don't convert into the very fine particles. If you convert into the very fine particles, there is a possibility for the compressed pack that we don't want. We want some loosened pack only here, so that solvent can pass through easily, right? And take this crude drug particles and you drop into the closed vessel, you add the solvent just to submerge and leave it for about 4 hours. Whatever pores or capillaries filled with air are completely removed, the solvent is entering inside and there is a process of swelling of the crude drug particle. It is leave it for about 4 hours. And maceration, you take this imbibed drug, you pack into this, you add the imbibed drug and arrange it uniformly. Right? And you pack it in a not very loose, not very tight, like that. Right? And you start adding the solvent, let it run, and a few drops are coming out. You close it now and we keep it for about 24 hours maceration. And once this 24 hours is over, you open this one, you regulate the flow rate. Suppose 5 drops are coming out from this percolator per minute. 5 drops per minute is coming out. Accordingly, you add the solution. Always solvent must be there above the packed bed. Right? Collect the 3/4 of the volume of the final extract, and now you take this 3/4 of the volume of the extract, and after that you take this packed bed, compress it using a suitable device, and we get some liquid, that expressive liquid. You mix these two, make up the volume with the remaining amount of the solvent, that is menstruum, and proceed for the filtration. This is the basic principle, basic process for the percolation. In detail, we'll see that now.